Hello and welcome to Textbook Engineering Problem. Today we're working out of Elementary Principles of Chemical Processes, 3rd edition. We're working on problem number 2.35. The problem statement says, the climactic moment in the film The Eggplant That Ate New Jersey comes when the brilliant young scientist announces his discovery of the equation for the volume of the eggplant. He gives an expression for the volume. 2.35 volume in feet, this is an empirical equation, equals 3.53 times 10 to the minus 2 exponent 2t squared. Okay, where t is the time in hours from the moment the vampire injected the eggplant with a solution prepared from the blood of the beautiful dental hygienist. Wow, this is an intense problem. Maybe PG, not G-rated, like most math problems. Some parental guidance suggested here. Okay. Injected the eggplant. Okay, so T is in hours. That's the important part. I'm getting distracted by vampires here. Okay, T is in hours. Part A, what are the units of 3.53 times 10 to the minus 2 and 2? Okay, well, as we've said before in a few of these other problems, previous episodes, the exponent term cannot have any units. Therefore, 2 has to have reciprocal units of so that t squared and 2 altogether has no units. So if t is in hours and we're squaring it, then t squared has hours squared. Therefore, 2 has to have reciprocal hours squared as its time, or as its units, so that it cancels out. The units cancel out. And that also means that if this expression has no units, then this expression, in order for this to have the same units, these have to have the same units. So 3.53 times 10 to the minus 2 has units of the same units as this term, because this term and this term need to have the same units, because there's only one term. So there you go. There's only one term on either, I should say, there's only one term on either side of the equation, the equal sign here. So in order for these things to be equal, they have to have the same units. Makes sense, right? Okay, so moving on from part A, let's do part B. The scientist obtained the formula by measuring the volume versus the time and determining the coefficients by linear regression. Okay. What would he have plotted versus what on what kind of coordinates? Okay. What would he have obtained as the slope and intercept of his plot? Okay. Well, let's turn this equation into something that looks more like a line. So we've got V equals A. I'm saying that A is this, and B is this. Okay, so A times the exponent of B t squared. Okay, well, we got to get rid of that exponent, so we got to take the log in order for this to look more like a line. Okay, that looks a lot like a line now. So let's define our line here. Where our model looks like this. Okay, that's a linear model. got two parameters, M and B. Now it says we need to calculate what would he have plotted versus what? Okay, so he would have plotted the natural log of the volume versus the time squared. On what kind of coordinates? You could do this on rectangular coordinates, or you could plot the volume on log coordinates. Either way. I like using rectangular coordinates, so that's what I'm going to use. What would he have obtained as the slope and the intercept? So he would have obtained B as the slope, so B is 2. So he obtained 2 as the slope, and as the intercept, he got the log of A. So the log of A is equal to minus 3.34. Okay. Part C. The European distributor of the film insists that the formula be given for the volume in meters cubed as a function of time in seconds. Derive the formula. Okay, so we've done similar problems. We've done similar conversions as this before, so this shouldn't be too bad. We just need to convert our parameters, A and B. Instead of being in hours, we change it to seconds, and we change feet into meters. Not too bad. All right, so let's do A first. Feet cubed. How many feet in a meter? That's a 3. In 1 meter. 1.25 meters cubed, and B is 2 per hour squared. And so to put it in seconds, we have we have 3,600 seconds per hour, and B equal to 1.54 times 10 to the minus 7 per second squared. Great. So that is it for problem number 2.35. Thanks for joining me. If I have made an error in this problem, let me know in the comments, and I will put it a correction in the comments as well. Try and post some sort of correction on that. If you need help on another problem from this book or another textbook that I'm familiar with, I can try and make a video on that to help you out. Thanks for joining me today, and I hope to see you in the next video. Thanks. Bye.